Every second, the global economy records billions of discrete actions. We track supply chain movements across continents, execute high-frequency financial trades, and log endless streams of API calls. Modern enterprise software is exceptionally good at capturing the execution. If a transaction occurs, the system knows exactly what happened and exactly where it took place. But standard databases miss a crucial dimension. They log the event, but they fail to permanently lock in the permission status of the actor at the exact millisecond that execution happened. This means a record of what happened remains vulnerable to challenge if the system cannot independently prove that the person or machine had the actual right to trigger it. This creates a specific liability known as the revocation paradox. Imagine an auditor signing off on a multi-million-dollar carbon credit report, or an AI agent executing a massive procurement order. The action clears today, but what happens 6 months from now, when that auditor loses their professional license, or the AI's permissions are downgraded? Traditional database architecture simply overwrites the past. The profile updates from active to revoked. Suddenly, the validity of every historical action that auditor took is thrown into doubt. The external buyers and regulators looking at the system today only see the revoked status. To prove the auditor was active at the time of the sign-off, they are forced to trust a private internal server log that can easily be altered. Internal authorization that erases historical state is not a true security control. It's an unprovable claim. To solve this, we have to look beneath the workflow. Authority Trail is a shared public protocol built on the Hedera network, designed to act as the permanent permission layer for digital systems. Fixing the revocation paradox requires a structural separation. We must pull the act of execution away from the proof of authority. On one side, we have the execution layer, powered by systems like DOVU OS. This environment exists purely to log the workflow and capture the audit trail of the actual event. On the other side is the authority layer. Authority Trail operates independently to record the live state of permissions, proving who holds the right to act. By keeping these functions apart, the high volume of daily workflow executions cannot overwhelm or distort the highly specific, time-sensitive record of who holds power. Here is how that digital permission actually moves through time. Step 1 is the request. An actor pings the network, requesting a specific role from an issuing body. Step 2, approval. The authority grants the credential and opens an immutable time window directly on the public ledger. Step 3 is the action. The actor performs their job. Simultaneously, the ledger stamps their active permitted status into the record at that exact millisecond. Step 4 is revocation. The issuing body changes its mind, terminating the role with immediate effect. The future timeline goes dark, but the past remains locked in green. Which brings us to Step 5. A relying party verifies the data. They query the ledger and instantly see both truths at once. The role is currently revoked, but the historical record shows it was valid when the action occurred. Because current status and historical validity live on the exact same public record, any attempt to rely on stale authority is immediately exposed. This logic scales directly to machines. We are entering an economy defined by millions of machine-to-machine actions executing every single second. Before autonomous AI agents can execute automated trades or initiate sensitive data transfers, they must securely check live on-chain rollbanks to ensure their permissions are active. Global supply chains can map strict delegation events across international borders, confirming customs and compliance handoffs without relying on any single manufacturer's private server. Verifiable historical authority is the necessary prerequisite for deploying autonomous systems into high-stakes environments. We are moving away from trusting internal, easily altered databases, shifting toward a global, independently verifiable authority state. Disputes over stale authority, forged credentials, and retroactive liability disappear when the timeline cannot be rewritten. From carbon credit buyers confirming validation standards to enterprise risk managers auditing multi-party supply chains, everyone has access to the exact same time-stamped reality. As the world automates execution, the ultimate currency of trust is the ability to undeniably prove exactly who had the right to act and when.